graphs of categorical data, or also called qualitative data. Here we have an example of eye color of 10 newborn babies. 7 had brown eyes, 2 had blue eyes, and 1 had hazel eyes. We can make, there's several types of graphs we can make. One is called a bar graph. It's a little bit like a histogram, except this, one of the differences is that the scale for the variable is not numeric. So our scale here will have values brown, blue, and hazel instead of numbers. So usually the variable will go on the horizontal scale, and then the frequency or the number of babies will go on the vertical scale. Although it can be done either way, you can switch those around, and you'll see it done either way. Okay, so 7 had brown eyes, so we make a bar going up to 7. And then 2 had blue eyes, we'll make a bar going up to 2. And 1 had hazel eyes, we'll make a bar going up to 1. So it's similar to a histogram, but just as a clue that this scale is not numeric, we leave little gaps between each bar. For a histogram, there's no gaps unless there was no values for that, no cases for that value of the variable. So if you skip a number, if there's no rainfall between 0.5 and 1, for example, you would have no bar. You'd have a gap in the graph. But otherwise, for a histogram, for numerical data, you don't have graphs between the bars. But for a categorical value, just as a hint that these are categories, not numbers, we leave equal-sized gaps between each of the bars. That's kind of a tradition. And the other thing about bar graphs compared to histograms is that we don't talk about skewness. You might think that this graph is skewed right because the longer tail is on the right, but if we put the brown in the middle instead of on the left side, then it's going to look symmetric. Or if we put brown on the right side, then it's going to look skewed left. So the order of the bars is arbitrary. So we don't discuss symmetry versus skewness of the bar graphs. We can this bar graph just tells us that the largest category here was the brown eyes, and then the second smallest was blue, and then hazel. If the bars are either in descending order or ascending order, like from smallest to largest or largest to smallest, then it's called a Pareto chart. So you might see that terminology, but it's just a way of making a bar graph, where you put the bars in order from smallest to largest or largest to smallest, called a Pareto chart. So this is actually a Pareto chart because we went from the highest frequency down to the lowest frequency. Now for the bar graph, we could use the relative frequency instead of the absolute frequency. So on my vertical scale here, I had the absolute number of babies that had each eye color. But we could also do the relative frequency. For the brown eyes, it would be 7/10, which is, if you divide, make it into decimal, 0.7. For the blue eyes, there are 2 out of 10 babies. 2 divided by 10 is 0.2. For hazel eyes, 1 divided by 10, 1 out of 10, 0.1. And let me extend the scale here. I should have extended the scale here, 0.7. So for the this is let me redo my scale here. 2, 3, 4, 5, 6, 7, 0.7, 0.5. Okay, so we have brown, blue, and hazel. Okay, so we have the relative frequency was 0.7 for the brown eyes, so the bar goes up to 0.7. And for blue eyes, 0.2, the bar goes up to 0.2. And hazel, 0.1, the bar goes up to 0.1. Okay, so it's basically the same graph, it's just the vertical scale is different. It's the same graph we had before. We can see that the most frequent category was the brown eyes, most frequent was blue eyes, and so forth. We could also do percentages. The brown eyes as a decimal is 0.7. If we make it into percent, multiply by 100 or move the decimal point over, that would be 70% of the babies had brown eyes. 0.2 times 100, 20% had hazel eyes. 0.1 times 100, 10% had hazel eyes. So it's the same, be basically the same graph, except our vertical scale now is just labeled differently. Now it's labeled in percents instead of something else. So for brown eyes, the bar goes up to 70%. Blue eyes, the bar goes up to 20%. Hazel goes up to 20%. Okay. Okay. Another type of graph is a pie chart or a circle graph. Because we have 10 babies, we can divide the pie into 10 pieces, and then we want 7 slices for the brown eyes, because 7 babies had brown eyes. 1, 2, 3, 4, 5, 6, 7. 7 babies, brown eyes. 2 of the babies had blue eyes. This is up here. And 1 baby, hazel eyes. That's just 1 slice here for the 1 baby with hazel eyes. That's a pie chart. And with pie charts, again, we could use relative frequency or percents. So the 7 out of 10 had brown eyes, so as a decimal 0.7, and 2 out of 10 had blue eyes, as a decimal 0.2, 1 out of 10 hazel, as a decimal 0.1. So we want 7 slices for the brown. 1, 2, 3, 4, 5, 6, 7. 0.7 brown eyes. 2 slices, or 2/10, 2 slices for the blue. 0.2 blue eyes. And 1 slice, 0.1 hazel. So that's as a decimal. We could also do a percent. And 0.7 times 100 would be 70%. Brown eyes. 0.2 times 100, 20%. Blue eyes. 0.1 times 100, 10%. Hazel eyes. So we want 7 of the 10 slices. 1, 2, 3, 4, 5, 6, 7. Brown eyes. 20% blue eyes. And 10% hazel. One slice there. Okay, so bar graphs and pie charts can be used for categorical data. Pie charts are usually not used in professional publications because they take up a lot of space for the amount of information they convey. The histograms and dot plots, stem plots, and box plots are used for numerical data. They're not used for categorical data. And that concludes this presentation.